Everybody, Mr. Smith here, and in today's video lesson, we're going to review how to find the maximum and minimum of a quadratic function for all the various forms. So this will be a review of a lot of skills you did in your grade 10 course. So let's get started. And full disclosure, this is the 6th video I've shot today. So I've been shooting for maybe 3 or 4 hours at this point. So hopefully I don't make any mistakes here. Do my best. I'm sure you guys will point out if you find any. So as I kind of teased in our last video, a lot of applications are very interested in finding a max or min. You want to maximize revenue if you're a business. You want to maximize efficiency if you're doing any tasks. A lot of times you want to optimize something. Sometimes that means maximizing, sometimes that means minimizing. But both of those cases, as far as quadratic functions go, involve finding the vertex. So we're going to review how do we find the vertex today. So the easiest case is when you just have your function in factored form, you can just read off the vertex. So in your grade 10 course, you learned that that's just given by, in this form, a times x minus h squared plus k, the opposite of this number and just this number on the end. So h and k. And that's why we have the negative in this form to indicate that it is the opposite of this guy that's the vertex, hk. So the vertex for our first function, the opposite in the brackets is 5, positive 5, and then the y value of the vertex will just be minus 6. Do you want to take a second and pause the video and try the last two? Where would the vertex of those quadratic functions be? Unpause when you're ready. I'm going to do them right now. So the vertex of the second guy would be positive 1.5, 6. And for the last guy, would be 2/3, positive 2/3, and 4/5. So it's always the opposite of what is in the brackets there. I suppose in the future, I might make one that has if this was x plus 5 squared, for example, then our vertex would change to minus 5, minus 6, right? So those are the easy cases, but it's never so simple, right? So the second case is if you have your quadratic function in factored form. You can find the vertex by finding the zeros and then using the axis of symmetry. So I want to show you what I mean by that. We're going to do 2 examples, and we're going to sketch the first one. So here we have a function, quadratic function, it's in vertex form. So after your grade 10 course, you should be able to pick off the zeros or the x-intercepts. So what are they here? So here are zeros. And remember, it is the opposites of these two guys. So it's positive 1 and negative 5. Those are our 2 zeros. Now, I asked you guys to make a sketch of this one. So why don't we just make a sketch as we go? So I know that the zeros for this function are at positive 1 and negative 5. Our goal is to find the vertex. For any parabola, you know where the vertex is in relation to the x-intercepts. Because parabolas are symmetric, the vertex will be halfway between those guys along the axis of symmetry. Well, where is the axis of symmetry? I'll do short form AOS for that. For this particular parabola, well, it's halfway between the zeros. Well, it's halfway between the zeros. I mean, you guys could probably do the mental math, but if you want to find halfway between 2 numbers, you can find their average. Add them, divide by 2. Negative 4 divided by 2 is negative 2. So the vertex is at somewhere along x equals negative 2. What's the y value? Well, let's find the y value when x equals negative 2 by plugging it in and using our function notation. F at negative 2 we'll plug it in. So you might be able to hear the people having a conversation outside my classroom right now. Just doing some building maintenance. It is what it is. We carry on. So 4 times negative 3 times 3, that's negative 36. So squeezing that in, Our vertex is at -2, -36. And we can make a rough sketch of that. Good enough. Yeah, so if you have the factored form, you can read off the zeros, find the axis of symmetry, and plug that in to find the vertex. It's not so bad. So can you guys try that with the last one? I have thrown a little twist in the last one. Can you pick off the zeros from that guy with the brackets looking a bit different? So let's talk about the zeros. So if it's not obvious, like sometimes factored form might not be perfectly as it is in part A. You might have to think, well, what makes this first bracket equal to 0? We're finding the zeros, right? So we're just thinking, what makes it 0? Well, 30 minus 30 equals 0, solving that little equation. That's 1 0. And what makes the second bracket equal to 0? Well, this one might not be as obvious, so maybe we'll just use our solving equation skills. Bring over the 200 minus 200. Divide both of the sides by 4. You get -40. So sometimes you have to work for the zeros like we did here, even if it's factored. Okay, so what's our axis of symmetry? Well, what's halfway between 30 and -40? Some of you might be able just to do the mental math. If you're unsure, average them. 30 plus -40 divided by 2. That's -10 divided by 2, or -5. We know that our vertex occurs along the axis of symmetry at x equals -5. So what's its y value? Well, let's find that out. Find g at -5. So we have 30, subtract -5. And in our second bracket, 200 plus 5 times -5. Well, 30 subtract -5, that's 35. 5 times -5 is -25. 35 times, 200 minus 25 is 175. Now, 35 times 175, I definitely have been shooting videos too long. I cannot do that in my head, at least easily. So 6,125. So we found the vertex. The vertex for this particular quadratic function is at -5, 6,125. So the big idea is if that you have factored form, you can find the zeros, and like in B, you might have to work a little bit for them. Find the axis of symmetry, plug in to find the vertex. All those steps, each one is manageable, so we can do it. All right, so that's when it's in factored form. Now, the final case is, what happens if your quadratic function is in standard form? Well, depending on who your teacher is in your grade 10 course, you either learn one method or two methods. I'm going to show you guys two methods and then let you guys choose which one you like to use best. So the first method is actually the method that the grade 10 curriculum requires you to learn. It is a useful skill, and there are reasons why we do want to know this method, but it's not everybody's favorite choice. So I'm going to do a couple examples with you guys, and then I'll show you a second method. But this idea of completing the square, because you know how vertex form is a times x minus h squared plus k. The idea is like vertex form has this, perfect square. So how do we kind of create one? We have to, because there's no perfect square. This is not a perfect square trinomial. So we kind of have to make one on our own. So what we want to do is take x squared plus 10x, and we want to find some number that makes that a perfect square trinomial. We want to complete the square. Now, we can't just add a number and it's going to change the equation, right? So what we'll do is we'll also subtract off that same number, and and we have a minus 7. So by adding and subtracting the same number, we don't change the equation at all. Now, what will give us a perfect square? So just think about what number plus itself gives you 10. That's 5, right? And what's 5 squared? Well, it's 25. So reasoning it out, just talking through it, to make a perfect square trinomial, we need a 25 in there. But because we're adding 25 and we have to subtract 25. Now, a formal way, just to kind of figure out that number that just works all the time, is you take your b value and you chop it in half by dividing by 2, and you square that result. So you get 5 squared or 25. 25 is the number you have to add, subtract. And then we're basically done. We created a perfect square trinomial, so we don't need to work hard to factor it. By our own work, this is x plus 5 squared, right? 5 times 5 is 25. 5 plus 5 is 10. And then negative 25 minus 7, that's minus 32. So we've completed the square, we've created the vertex form, and now we can read off the vertex. It's negative 5, negative 32. So that's great. Now, I have a second example of completing the square. That was a case where the a value was 1. What do we do if it's not 1? Well, we do have one step we have to do beforehand. So the previous one wasn't so bad because it was just x squared. So we want to take our problem in B here and make it just x squared. And we do that by doing some partial factoring. So whatever was in front of the x squared, you're going to take it out. And only that. So you're left with just x squared. Now, what are you left with when you divide 2/3 out of 8? So what's 8 divided by 2/3? All of your calculators can handle this, but we can just do the math too. Remember, when you're dividing fractions, that's like multiplying by the flip or the reciprocal. 8 times 3 is 24, divided by 2 is 12. So we're left with 12 minus 12x. And we only do it from the first two terms, and we leave the minus 5 out there. So by doing this trick, we can now use our previous method and complete the square in the brackets, and then just do some cleaning up. So we have 2/3 x squared minus 12x. What should we add, and what should we subtract? Well, what number plus itself gives you negative 12? It's negative 6. What's negative 6 squared? It's 36. If you couldn't work that out mentally, what we do is we take that value in front of x, we chop it in half, and we square it. Negative 6 squared is 36. And now we proceed. I like to, at this point, just do I like to multiply into 2/3. But keep all those three terms the same, and then just do 2/3 times minus 36. 2/3 times minus 36, 2/3 of 36 is 24. So we're left with minus 24 and our minus 5. And now one step and we're done. This is a perfect square trinomial. It's minus 6 and minus 6. So add to minus 12 and multiply to 36. So 2/3 times x minus 6 squared. And negative 24 take away 5 is negative 29. Whew, we did it. So the vertex is 6 minus 29. Now, in grade 10, the curriculum said the students need to learn that method. But moving forward, there's nothing that says we can't use other methods. And I don't know any people really who truly enjoy this method. I certainly can appreciate this method, but there are ways to do it that actually work for everybody and don't require any knowledge of factoring. So I like to share that method with you now. The second method we can do is using the axis of symmetry. Now, we haven't got to the stage where we've reviewed the quadratic formula, and maybe you guys have even memorized a song for the quadratic formula. But the quadratic formula was this. Given given the standard form of a quadratic relation, this formula tells you the x-intercepts. And you'll notice that the x-intercepts, it's always negative b divided by 2a plus a bunch of stuff, and then negative b over 2a minus the same stuff. Halfway between them will be negative b over 2a, and that's the axis of symmetry. And remember, if we can find the axis of symmetry, we can find the vertex. So, most students I teach prefer just using this formula for the axis of symmetry. I'm okay if you guys do that as well. So let's try it. So looking at our quadratic function in A, we'll use this formula for the axis of symmetry. So the axis of symmetry is negative b over 2a. So that's the negative of negative 12 over 2 times 4. So that's 12 divided by 8. And let's use decimals. I said you may use decimals for part B, but let's use decimals for part A too, no big deal. 12 over 8 is 1.5. So the vertex happens when x equals 1.5. Well, what is f at 1.5? Let's find out. 4 times 1.5 squared minus 12 times 1.5 plus 3. Now, guys, we just have to do some calculator work here. So I believe that's 4 times 1.5 squared. That's 2.25 times 4 is exactly 9. 12 times 1.5, that's minus 18 plus 3. So that gives us minus 6. So guys, we found the vertex. Vertex is 1.5 minus 6. And to me, that's not too bad. Little plug and play formula for the axis of symmetry, and then use the function to find the y value. So maybe you want to try the next one on your own using this method. So first we find the axis of symmetry. That will be negative 37 over 2 times negative 5. So that's negative 37 divided by negative 10. So that's positive 3.7. That's where the vertex happens. So what's the y value, or in this case, the h value? Now I did say x here. Maybe I should have used t, because this isn't f of x, it's h of t. So what is the h value when t is 3.7? Let's find out. Don't know why I have a decimal there. Well, I kind of do know why. It's because it's my 6th video of the day and I am tired. 3.7 plus 22. There is absolutely no way that I'm using mental math for that one. So let's crank that out. So negative 5 times 3.7 squared plus 37 times 3.7 plus 22. So I got 90.45. So our vertex is, in this case, 3.7, 90.45. So you have 2 methods to find the vertex. The first method, a bit more of an algebraic method. It's kind of elegant. I think it's kind of cool, but it requires you to be very good with, factoring. The second method is more of just an algorithm. It works the same way every time. You do negative b over 2a, you take that x value, you plug it in, you find your y value. So most of my students, and I'm talking like almost everybody, uses this method using negative b over 2a. But of course, feel free to use either one. All right, so now that we've reviewed methods to find the vertex, let's do a couple application examples. In this one, Louise throws a ball. Due to gravity, it moves through the air in a parabolic path. So the function that models the parabolic path is going to be quadratic. And what we're going to find is the time needed for the ball to reach a maximum height and to determine the maximum height. Now, you guys did this in grade 10. You guys did problems like this in grade 10, and we are doing some more in grade 11. And I'm surprised at how many students do this. But this question is pretty clear. You're looking for a maximum. What point on a parabola represents the maximum? It's the vertex. But so many people just read a question and see an equation and want to right away just like use a quadratic formula and find, the zeros. But this question wants the vertex. So that's what we're doing. And let's use our axis of symmetry method. So I'll use t for the time of maximum height. Negative b over 2a. So that's negative 44.1 over 2 times negative 4.9. Now, I believe I cooked this up to give a nice round number. So let's double check. So negative 44.1 divided by negative 9.8. Yeah, it works out to 4.5. So it's 4.5 seconds until it reaches a maximum height. And what is that maximum height? Well, let's find out. What is the height after 4.5 seconds? Just got to do some plug and play. Minus 4.9, 4.5 squared, plus 44.1 times 4.5, plus 1.5. Just got to crank that into our calculators. Let's do it. All right. And I'm not rounding. I'm just going to leave my exact answer here. I got 100.725. Louise has quite the arm on her, I must say. Or maybe she's on a different planet where gravity is less. But 100.725 meters. And so this is the maximum height. And we're done. But I need to really drill this into you guys. You're looking for a maximum or a minimum, you're finding the vertex. It's not overly complicated. You can use either of our methods, but this method works really good. I'd check it out. One more problem here, guys. So maybe you solve questions like this in your grade 10 course, but this is a kind of a classic grade 10 optimization question where you're selling something. And we know that, if you make your price too high, nobody will buy it and you don't make a lot of money. But if you make your price too low, you might sell a lot of things, but if your price is really low, you're still not making a lot of money. So you have, two extremes, and somewhere in the middle, there's some ideal price to give you a maximum kind of revenue or maximize your profit. So in this particular question, Rachel and Ken are knitting scarves to sell at the craft show. So the Wolf Reed scarf costs $6, and they're planning to sell them for $10 each. So last year at that price, $10, they sold 40. So they want to see if they can do better and make more money. So they conducted some research, let's say, and found that every time they increase the price by $0.50, they're going to sell 4 fewer scarves. So what we want to see is, okay, what price should we sell at to make the most money? And how much money would that be? All right, and we got Sayers there with his awesome scarf. This is when the Raptors were, they won. It was before the COVID hit. They had won 13 games in a row or something. And OG put him on scarves, or at least he said he did. Anyway, wanted to throw it. The Raptors just won their game 6 last night against Boston, so I wanted to toss in some Raptors here. I digress. Let's solve this problem. So if we want to find the maximum profit, first we need actually an equation for the profit. So the profit's pretty simple to calculate. How do we find the profit? Well, we take the total profit is the profit per scarf multiplied by, the number of scarves that we sell. And we can definitely come up with an equation for that. So in these kind of problems, the trick is to let our variable, our independent variable, I'll call it x, be the number of price increases. That's the trick to these for setting them up anyway. And every single problem like this starts off the same way. You let your independent variable be the number of price increases. So let's make an equation now, or a function. So profit, I'll use capital P. P of X, our independent variable. So what is the profit per scarf? So remember this, guys. So right now, so in the previous year, they sold the scarves for $10, but the wool cost $6 for them, right? And so for each scarf, they're originally just making $4. Why 4? That's because 10 minus 6 equals $4 per scarf. So that's the profit. Now, every time they increase the price, they make an additional 50 cents of profit. So we'll say plus 0.5 times the number of increases. They increase the price one time. Instead of making $4 per scarf, they're making $4.50 per scarf. They increase it 2 times, they're now making $5 per scarf. However, every time they increase the price, they sell less scarves. So last year they sold 40, but every time they increase the price, they're going to lose 4 scarves. And guys, we've created a function for the profit they're going to make for these scarves. Now let's think about which scenario we have here. The function we have is not in Vertex form. So unfortunately, we can't just read off the answer. But it is in factored form. So if you'd like, we can actually just find the zeros from here and do the problem that way. If you really like expanding, you could expand this to standard form and then use one of our methods to find the vertex. But since it's in factored form, let's find the zeros. So let's find what makes each bracket 0. From there, we can find the axis of symmetry. From there, we can find the vertex. And none of these steps will be overly complicated. So what makes that bracket 0? Well, moving the 4 over, 0.5x equals -4. 4 divided by 0.5, or -4 divided by 0.5, that gives you -8. That's our first x-intercept. Our second one, if you bring over the 40, it becomes -40. -40 divided by -4 is +10. So those are our 2 zeros. What's the axis of symmetry? Well, it's at the average of those two things. Add them, divide by 2. So that's 2 divided by 2. That's equal to 1. So what we actually know is 1 price increase maximizes profits. So without actually finding the y value, we've answered that part of the question. And guys, what does that correspond to for a price? If you increase the price one time, that's $10.50 per scarf, right? They cost $10 originally, and we're increasing the price. And what is that maximum profit? Well, what is the value of P evaluated at 1? So 4 plus 0.5, because I plugged in 1. 0.5 times 1 is 0.5. 40 minus 4, it's 4.5 times 36, which is 144. I think it's 162, but again, I am quite exhausted. It is 162. So they're going to make $162 of profit. Whereas last year, they sold 40 scarves at $4 profit. Last year, they made $160. This year, they made $162. So you might be thinking, well, $2, that's not a lot. But remember, think about businesses these days and the grand scale of manufacturing. If you can, save a few cents on a small scale operation, but you scale that up 100, 1,000, 10,000 times, you can see how your profits can really make a big difference. So what I need you guys to be able to do is, given any of the three forms, I need you guys to be able to pick off the vertex, the maximum or the minimum. So remember, from vertex form, you can just read off the vertex. From factored form, like in the last example we did, you got to pick off the zeros. Sometimes you have to do some work for them. Then you find the axis of symmetry, and that's where the vertex occurs. You just plug that in. When it's in standard form, you have a couple options. You can use this algebraic method of completing the square, or you can use the axis of symmetry formula. And moving forward, you have the freedom to use whichever method you like. I won't make you choose one over the other. So we'll obviously practice these skills together. But what's coming down the pipe? For our next thing we want to review, we're going to review solving quadratic equations that will involve using the quadratic formula. But I showed the quadratic formula earlier, and it involves the square root. And in certain situations, like a lot of times, when you square root a number, you don't get a nice whole integer. A lot of times, like if you're rooting 3 or 5 or like a number like 17, you get a really nasty decimal. And we'd like to avoid that and keep answers in exact form. And that's going to require us to learn some new rules about simplifying things inside square roots. It's actually pretty interesting, and I think a bit of fun. But that is for the next lesson. You guys are doing good. I know the last two review lessons were pretty heavy and lots of review content, but we have some time to work on them together. And I hope you'll reach out if you need some help. But until then, hope you're staying well. Have a great day, and we'll see you soon.